Under the tremendous sky, over a monstrous ruby star, one of the most splendid and generally recognizable among heavenly bodies, rules the skyline. It exists far beyond the scope of our total perception. This epic, grandiose object has the potential to produce energy so enormous that it could rival the combined brilliance of countless stars. This galactic behemoth, possibly on the brink of a catastrophic event, could soon erupt with such power that its glow might outshine the collective radiance of a billion suns. The pivotal question, however, is whether mankind is prepared for the consequences of such an event. This giant red star, often called Goliath, lies relatively close to Earth and has become a subject of intense interest and debate within both the scientific community and the general public. Recently, the star underwent a significant change that has raised alarms and sparked heated discussions about its future trajectory. The most concerning possibility is that this change could indicate the early signs of a supernova, a catastrophic event marking the final stage of a star's life cycle. If Alpha Orionis, its scientific designation, were to run out of nuclear fuel, it could collapse under its own gravitational force, triggering a tremendous explosion. The very notion of such an event causes concern not only for scientists but for all of us on Earth, as its potential repercussions could be unprecedented. Alpha Orionis, easily distinguished by its rich red hue, holds the distinction of being the largest and brightest star in the Orion constellation. Using advanced tools like NASA's Hubble Space Telescope, astronomers have closely monitored its behavior, particularly in 2019, when it experienced a massive loss of mass, an unusual phenomenon for stars of its type, which has raised concerns in the scientific community. While our Sun frequently experiences coronal mass ejections, the extraordinary mass loss observed in Alpha Orionis has prompted a reassessment of what occurs during the final stages of a massive star's life. Scientists are divided on the exact distance of Alpha Orionis from Earth, with some estimating it to be as far as 1,200 light-years away, while others suggest it could be as close as 724 light-years. The challenge in determining its precise location arises from the vast distances involved and the unique characteristics of red giants. Despite uncertainties about its exact position, Alpha Orionis continues to captivate astronomers, remaining one of the most dramatic objects in the night sky, shining several times brighter than our Sun. However, this extraordinary glow comes at a considerable cost, as Alpha Orionis is consuming its nuclear fuel at an accelerated rate, hastening its journey toward the inevitable end of its life cycle. Once it exhausts its fuel supply, the star will likely collapse, potentially forming either a neutron star or, in a more catastrophic scenario, a black hole, depending on the nature of the explosion. This raises an important question. Could Alpha Orionis pose a threat to Earth? If a supernova were to occur within just a few light-years of our planet, the consequences would be devastating. A supernova can release an unimaginable amount of energy, potentially exceeding that of entire galaxies. Even though Alpha Orionis lies at a considerable distance from Earth, the implications could still be far-reaching. The last recorded supernova event within our galaxy occurred in 1604, and since then, humanity has not witnessed a similar occurrence on a local scale. However, a major supernova exploded in 1987 in the Large Magellanic Cloud, located 169,000 light-years away. While this explosion significantly affected its immediate surroundings, it posed no direct threat to Earth. Still, these rare events serve as stark reminders of the immense power of supernova explosions and the potential dangers they present. A supernova, particularly one occurring near Earth, could create a danger zone surrounding the stellar explosion. The risks to life on Earth should be considered within the broader context of cosmic events. While supernovae are relatively rare, gamma-ray bursts, GRBs, pose an even greater threat. These bursts can devastate entire planetary biospheres, bombarding them with lethal radiation. For example, GRBs have the potential to destroy a planet's ozone layer, leaving it vulnerable to harmful ultraviolet radiation from its star, effects that could persist long after the burst has faded. This looming threat of GRBs has become a focal point for current research, shedding new light on the potential dangers of stellar explosions that result in such catastrophic events. When massive stars explode as supernovae, their brightness can surpass that of entire galaxies. This raises a fundamental question. What would happen if Alpha Orionis were to undergo a similar transformation? If it were to explode as a supernova, it could become the second brightest object in the sky after the Sun. In terms of visibility, even at a significant distance, the energy released in such an explosion could be so intense that it might be visible during daylight hours. This breathtaking spectacle would cast shadows at midday, offering a striking yet unsettling experience for observers on Earth. While the visible light emitted by a supernova would undoubtedly be a stunning sight, the real danger lies in the high-energy radiation accompanying such an explosion. This radiation, primarily in the form of X-rays and gamma rays, could have far-reaching consequences. One of the primary concerns is its potential to deplete Earth's protective ozone layer. Without the ozone layer, life on Earth would be exposed to harmful levels of ultraviolet radiation, possibly leading to mass extinction events. The dangers posed by a supernova do not dissipate immediately after the explosion. The remnants of the blast, including shock waves traveling at nearly the speed of light, would continue to pose threats as they propagate throughout the solar system. These shock waves could cause further damage to the ozone layer, exposing Earth to an even greater risk of harmful radiation, which would only increase over time. Additionally, the long-term effects of the energy released by a supernova could last for centuries, leaving lasting damage to the planet. Interestingly, some studies suggest that Earth may have already been affected by the aftermath of a supernova in the past. Elevated levels of iron-60, a radioactive isotope produced during supernova explosions, have been found in deep-sea sediments and lunar soil, indicating that Earth has likely experienced the fallout from such an event in its geological history, possibly within the last few million years. At present, no known supernova candidates pose an immediate threat to Earth. However, ongoing research continues to uncover new potential risks, particularly from supernovae capable of emitting long-range lethal radiation. These supernovae occur when a dying star is surrounded by a massive shell of material, and the shock waves from the explosion interact with this material, creating intense X-ray radiation that can travel vast distances through space. This radiation has the potential to affect planets within a 150 light-year radius. Fortunately, no such candidates have been identified near Earth. Nonetheless, this research has provided new insights into the concept of the habitable zone, the region of space where conditions could support life. It appears that this zone may be narrower than previously thought. The outer regions of galaxies may lack sufficient star formation to support the development of rocky planets, while the inner regions, where stars are born and die more rapidly, may present risks due to the frequent occurrence of supernovae. As scientists continue to investigate the remnants of supernovae, they are discovering that these cosmic leftovers can give rise to new stars, forming stellar nurseries from the material ejected during the explosion. This process highlights the interconnectedness of the universe, where the death of one star often leads to the birth of another. Moreover, supernovae have proven to be invaluable tools for measuring cosmic distances. Type Ia supernovae, in particular, are used as standard candles, allowing astronomers to measure distances between galaxies with remarkable precision. Astronomers have refined how we might interpret the universe's limitlessness and provided imperative data about dark energy and the accelerating expansion of the universe. The remnants of supernovae, consisting of the material ejected during the explosion, play a crucial role in the formation of new stars. These remnants act as stellar nurseries where new stars are born from the gas and dust left behind. This recurring process, where the death of a massive star leads to the creation of new generations of stars, drives the evolution of galaxies and contributes to the ever-changing structure of the universe. As astronomers continue to study supernova remnants, they are discovering that new stars can emerge from the gas and dust in these regions even millions of years after the initial explosion. Supernova remnants, with their complex compositions, are also one of the universe's primary sources of heavy elements. Elements such as iron, gold, silver, and uranium are formed in the extreme conditions of a supernova explosion and are scattered into the interstellar medium, enriching the matter that will eventually form new stars, planets, and even life itself. Without these heavy elements, the solar system, and indeed our very existence, would not be possible. Supernovae, therefore, are not merely destructive events. they also play a vital role in the creation of the very elements that make up the stars and planets we observe today. Furthermore, the study of supernovae has expanded our understanding of the universe's expansion. By observing the brightness of type Ia supernovae, caused by the explosion of a white dwarf in a binary system, astronomers can measure cosmic distances with remarkable precision. These standard candles have revolutionized our ability to map the universe, providing critical information about dark energy and the accelerating expansion of space. Despite the significant advancements in our ability to measure cosmic distances, the potential dangers posed by supernovae cannot be ignored. While the likelihood of a nearby supernova affecting Earth remains low, the long-term consequences of such an explosion could be profound. As mentioned earlier, supernovae emit intense radiation that could disrupt the solar system's environment. This radiation could interact with Earth's atmosphere, depleting the ozone layer and exposing life to harmful ultraviolet radiation from the sun. Without the ozone layer, survival on Earth could become increasingly difficult, if not impossible. Additionally, the shock waves from a nearby supernova could disturb the structure of the solar system. These waves might compress the interstellar medium, potentially triggering the formation of new stars or altering the orbits of objects within the solar system. In the worst-case scenario, a nearby supernova could disrupt the delicate balance of the solar system, leading to catastrophic changes in planetary orbits and possibly even threatening Earth's existence. The study of supernovae and their remnants also raises intriguing questions about the future of the universe. As stars die and supernovae occur, their remnants can eventually form black holes or neutron stars, two of the most enigmatic and extreme objects in the universe. Black holes, in particular, are regions of space where gravity is so intense that not even light can escape. These objects are believed to be the final stage for the most massive stars, and their formation is one of the most fascinating phenomena in modern astronomy. Despite their destructive nature, supernovae are essential to the ongoing evolution of the universe. The materials they release into space serve as the building blocks for the formation of new stars and planetary systems. As new generations of stars are born, the cycle of stellar life and death continues, driving the evolution of galaxies and contributing to the ever-expanding nature of the universe. In conclusion, while the potential threat of a supernova explosion remains a distant concern for Earth, the study of these events is crucial for advancing our understanding of the universe. Supernovae not only provide valuable insights into the life cycles of stars but also offer critical information about the chemical composition of the universe and the ways in which galaxies evolve over time. As we continue to explore the vast expanse of space, our understanding of these dramatic cosmic events will deepen, offering a clearer and more comprehensive view of the universe's past, present, and future. Moving forward in our exploration of the cosmos, it is evident that studying these massive celestial phenomena, like supernovae, will continue to reveal new layers of understanding about the universe and its intricate mechanisms. Each step in this research brings us closer to grasping the true scale of how stars live, die, and contribute to the dynamic, ever-evolving universe around us. Supernovae and their aftermaths, such as neutron stars and black holes, represent some of the most fascinating and mysterious aspects of astronomy. These phenomena raise profound questions about the ultimate fate of stars and their role in the larger cosmic system. The processes that lead to a supernova explosion involve incredibly complex nuclear physics, yet their resulting impacts stretch across vast distances, influencing the formation of entire galaxies, the birth of new stars, and the enrichment of the universe with essential heavy elements. Understanding how these events unfold and the conditions that trigger such explosive occurrences helps scientists piece together the puzzle of stellar evolution. Beyond their fundamental role in star formation and the creation of elements, supernovae serve as a crucial tool for measuring cosmic distances. By analyzing the light from these dramatic stellar explosions, astronomers can create more accurate maps of our universe, tracking the expansion of space and the distribution of galaxies across vast distances. These measurements are essential in determining the age, scale, and structure of the universe, leading to groundbreaking discoveries about the mysterious force known as dark energy, which appears to be accelerating the expansion of the universe. This precise ability to measure distances using supernovae has had far-reaching effects throughout astronomy. By providing more detailed and reliable methods for gauging distances across the cosmos, we have gained a deeper understanding of the rate at which the universe is expanding and how galaxies are evolving. The presence of dark energy, first inferred through observations of distant supernovae, has reshaped our understanding of the universe's future, suggesting that the cosmos is not just expanding but doing so at an accelerating rate. Yet, despite the incredible knowledge gained from these supernova studies, the potential dangers of a nearby supernova explosion remain a key concern. While such an event is unlikely in the short term, the possibility, however remote, demands our attention. The devastating effects that accompany supernovae, particularly the radiation and shock waves they generate, can significantly impact nearby planets. If Earth were to fall within the range of such an event, the consequences would likely be catastrophic, from the destruction of the ozone layer to the disruption of the solar system's delicate balance. Understanding these risks forces scientists to consider how life on Earth could be affected by cosmic events. If the ozone layer were to be depleted by radiation from a supernova, Earth's atmosphere would be left vulnerable to. However, perhaps the most profound aspect of supernovae is not their destructive impact but their fundamental role in shaping the broader cosmic picture. As stars die, they create the conditions for new stars to be born, fueling the ongoing evolution of galaxies and enriching the universe with elements essential for life. This intricate dance of creation and destruction shapes the universe as we know it and deepens our understanding of the forces that drive the cosmos forward. Supernovae remain some of the most exciting and mysterious phenomena in astronomy, providing new insights into the universe's past, present, and future. By continuing to study these events, we uncover not only the secrets of star death and rebirth but also the ultimate fate of the universe itself. Through this research, we are reminded that we are, in a sense, part of an ever-evolving cosmic cycle, and our understanding of this cycle helps us grasp our place in the vastness of the universe.